Okay, let's make some basic observations about absolute values so we can understand how to write absolute value functions as piecewise defined functions. So here's an example. Sorry about that. The absolute value of 5 is 5, and the absolute value of negative 5 is also 5. The absolute value of 8 is 8. The absolute value of negative 8 is also 8. And that's enough, I guess. So if the number inside an absolute value is positive, then the absolute value is that number itself, right? This 8 is positive, so the absolute value, that's also 8. If the number inside is negative, then the absolute value will be the opposite of what was inside, and the same thing here, right? So in general, opposite means to multiply by negative 1. So what we could say is the absolute value of triangle, whatever triangle may be, will be triangle if triangle is positive, right? If the number inside is positive, then the absolute value is that number or expression. The absolute value of triangle is the opposite of triangle if triangle is in fact negative. Now, how do you write algebraically the opposite of something? Well, that simply means multiply it by a negative. Okay? So we can now take any absolute value function and write it as a piecewise defined by doing this. The function absolute value of triangle is going to equal, it will be triangle if triangle is positive, so I'll say greater than 0, and in fact we can go ahead and say greater than or equal to, because if it's 0 inside you get 0 out, so we can say that as well. If what's inside is negative, if triangle is less than 0, then you get the opposite of what's inside. So if this were a negative 5, you'd get the opposite of that. So the opposite of triangle would be negative triangle, right? You multiply it by negative to make it positive. So this is how you deal with absolute value functions and write them as piecewise defined, which is useful when you're trying to evaluate the limit of an absolute value function. Let's practice this a little bit. Here's an absolute value function. I want to write it as a piecewise defined function. So what I do is I say f of x equals, now if what's inside here, this triangle x minus 3, if what's inside is positive or equal to 0, then the output's going to be whatever's inside, right? If what's inside is positive, then I get what's inside to be my absolute value. If what's inside, x minus 3, is less than 0, then I get the opposite of what's inside, so negative times x minus 3. And now we just have to make sure that our domain restrictions over here are in terms of x, so I need to add 3 to both sides of each of these inequalities. So I'll rewrite it as f of x equals, the first one's going to be if x is greater than or equal to 3 by adding 3 to both sides. The second one's going to be if x is less than 3, and I'll leave these alone. It's either going to be what's inside or the opposite of what's inside. So this is the piecewise defined version of this absolute value function. Let's try this one. We're only worried about the absolute value down here on the bottom, so if what's inside is positive, then I'm going to have what's inside to be my output. Now notice I didn't write or equals to, because this 2x plus 3 can't equal 0 because it's in the denominator, so we have to pay attention to that. So if what's inside there is positive, then on bottom I'll just get what's inside, and on top there's no absolute value, so I just copy it down. So that's one possible output. If what's inside the absolute value is less than 0, then I get the opposite of that, so on top I don't do anything again, but on the bottom I get the opposite of 2x plus 3. Okay? And so now what I'm going to do is try to simplify these and solve my inequalities. So this first one, I factor the top and then I can cancel my 2x plus 3's and I just get x. If I solve this first inequality, I get x is greater than negative 3 halves. Let's do the same thing on the second. Factoring the top, I can cancel my 2x plus 3's, and x divided by negative 1 is negative x. Solving the second inequality, I get x is less than negative 3 halves. This is the piecewise defined version of this absolute value.